Hey everybody. All right, so I'm not here today, obviously. So what we're looking at is going to be a very quick video on just some isotope information. We're just working on finishing the Changeium activity, and that's pretty much it. So all I've got today is just I want to go over one of those isotope kinds of questions. I know last week we already went over the whole money thing, okay? Don't overthink isotope abundance. It's the same as what we talked about last week with the whole, percent abundance of your coins, the average worth of one of your coins. Again, we saw this last week that out of all my 75 coins, my average worth of one of them was 7.47 or 7.48 cents based on the math. Okay. Again, none of our coins is worth 7.48 cents, but it's just an average, okay? So if I had billions of coins and the percents were still the same, my average worth of one of those billions of coins would be 7.47 cents. Now imagine counting billions of coins. It would take you lifetimes to do that. All right, so we're not going to do that. So for isotopes, it's the same idea. All right, because every single element, I'm going to show my P table, every single element, like magnesium, for instance, has an average atomic mass, all right? And every single element has a number of stable isotopes, okay? And so the average is determined by doing the exact same math that we did on our assignment using this equation, all the stable mass numbers with their percent abundances. If you do the math, add them all together, add them. That's lovely. Add them all together, you do get the average atomic mass. All right. But what I want to do is go over questions like 8, 9, and 10. I'm not going to do 8, 9, and 10 because that's for you. But I want to do an example of an element that is like number 8 and like number 9, not like number 10. That's for you to try to figure out. But let's look at number 8. So number 8. We're trying to basically use some information, use averages and also the only two stable isotope masses to kind of figure out, decipher which isotope is more abundant in nature. So silver is one of the elements that only has two stable isotopes. One of them is 107 and one of them is 109. The average mass of one of those in nature, out of the trillions and whatever insane number of silver atoms in the universe, the average mass of one of them is this right here, 107.87 atomic mass units, or AMUs. So there's only two silvers to choose from. Is it 107 or 109? Which one is more abundant? Which one's more popular, more common in nature, if this is the average? To do that, I want to look at one that's similar. This is not on the assignment, but it's the same idea. So potassium is one of the elements that has two stable isotopes. The two mass numbers are 39 and 41, respectively. These are the two. Why isn't potassium 40 stable? I don't know. It's just not. Okay. This is not a stable isotope. These two are, though. So K39 and K41. The average mass of a potassium atom is 39.098 atomic mass units. This is, again, on your P table. So knowing this, which isotope is more abundant and how do we know? So for how do you know, it's not, oh, I guessed, I figured it out, it was a 50-50 chance. That's trash, okay? Throw that in the garbage. So if we're given only two choices, it's actually not that bad to figure out. There's no guessing game, because it's all based on which one it's closer to. All right, so which isotope the average is closer to. And the reason that works, I want to show a little number line here. So you've all done number lines before. So the only two isotopes of potassium are 39 and 41. So look at the number line. And the average mass of one of those is right here, 39.1, you can call it, 39.1. Oh, look, it's closer to 39 than 41. So the answer for this is that K39 is more abundant. All right, it has to be, because the average is closer to 39 than it is to 41. All right, now again, if the average atomic mass was like 40.5 atomic mass units, if it was closer to here, Like, well, then yeah, K41 would be more abundant because the average is closer to that one. Now, again, this doesn't work with every single problem like this. It only works when you have two isotopes. All right, I want to show you why. So again, if you have two isotopes, it's pretty straightforward. Which one's it closer to? There you go. But here's a problem. Let's say, just for fun, all right, this is just hypothetical, but it's the same idea. Let's say that potassium has 5 stable isotopes. Now, I didn't plan this, but I just want to, let's bring this to the front. Let's say potassium has 5 stable isotopes. Let's say all 5 of these are stable. K38, K39, K40, K41, K42. Let's say the average atomic mass of potassium was like right there. Now, what if my question was, which isotope is most abundant? Is it 38, 39, 40, 41, or 42? The answer to this is I don't know. Okay. In the same regard, the same idea as the coin one. Again, if you ever ask me a question about this assignment, I'm always going to relate back to the coins because it's the exact same thing. But again, people think chemistry, they think, oh, it's impossible, but we did it with the coins. Same idea. There's nothing different. So in the same regard, look at what we did last week. This is similar, 1, 5, 10, 25 to 38, 39, 40, 41, 42. Same idea. All right. My average worth of a coin is 7.48 cents. So it's stuck between the nickel and the dime. Okay. In the same aspect of this average is stuck between 39 and 40. So in the same, same idea here, if you ask me, or if I ask you, hey, which, given my average worth of a coin, 7.5 cents, which of these coins was most abundant in my collection? The answer is I don't know. It could be nickels, it could be dimes, it could be pennies. I mean, it was pennies for me, but how would you know that? Just given the average, if it's stuck in the middle of all the possible weights or the possible worths? The answer is you can't figure it out. The only time you can figure it out is if you're given 2 choices and the average is closer to one of those 2. There's a way you can figure it out if you have a bunch of choices and the average is really close. For instance, if the average of these 5 was like 38.1, well, yeah, look at the number line. Look how close it is to the lowest mass. So the average is closest to the lowest, so therefore the lowest has to be most abundant. It's just how numbers work. It's how math works, okay? It's how life works, okay? But if the average is stuck somewhere between these ones, like even if it's like 40.4, you don't know. You could have most 41s, you could have most 40s, you could have most 42s, but there could be a lot of 38s that destroy all the top 42 masses. So you don't know. So again, looking at these questions, you really have to just focus on if there are only 2 isotopes, which one is closer to the average. If you have a lot of isotopes, like number 10, it kind of depends. So you have to look at the average, and that's what number 10 is looking for. So that's really it for today. It's due today, okay? So take your time on it. Work with your peeps, okay? We're not in remote anymore. I know you're still watching the video, but that's how it is. So take it easy, everybody. Due today. Have a good one.